Hi everyone. Today I'm going to be covering this paper on the GIANT framework, which is a geometrically aware interactive graph neural net for predicting protein-ligand interactions. Um, that probably sounds pretty similar to a lot of my recent work developing BindSmart and BindSmart-based models, because it is, but I will point out a few key differences along the way. So, as illustrated here in Figure 1, like our work, they take three-dimensional ligand-bound protein structures and attempt to predict a binding affinity. They use atom-based nodes, so that is unlike our work. We use protein residues and ligand atoms. They use protein atoms and ligand atoms with their edge features representing things like distance, dihedral angle, and polar angle. And so you can see in Figure 2 how they partition those angle domains. And that is sort of what's encoded in their atom-to-atom edges. And so we have heterogeneous edges that encode perhaps more nuanced interaction information, whereas they just have these sort of one type edges. Regardless, beautiful model, absolutely a beautiful model. I recommend checking out Figure 5 if you're curious about their architecture, but I will go through some key steps. So they start with this 3D GNet, which is a geometric network that iterates essentially message passing from edge to node, node to edge, stepwise iterating over the distance, polar angle, dihedral information to sort of create that geometric picture. And then from there, they pass the geometric information to PyNet, a pairwise interaction network. So that captures a more global picture of the interactions. That involves this molecule level attentive interaction, pooling, and that that gives the model a better idea of the more influential edges and atom-to-atom pairs. But then they also do this type level pairwise pooling, so that handles things like contact patterns between, for example, nitrogen and carbon or carbon and oxygen. And then all of that information goes into this multitask learning objective. So that's merging the geometric and interaction constraints for this final regression prediction. And the result is a pretty incredible model, great performance, very generalizable. And so they compare Giant, which is on the model on the far right of each of these bar plots, to a good number of other pretty state-of-the-art binding affinity prediction models. And so these plots are root mean squared error and mean absolute error. So the lower the score, the better the model. And as you can see, Giant is outperforming all of the others on this very general PDB bind dataset. They also offer a pretty neat ablation study that I recommend checking out, and really just highly recommend the paper. It's great. So thank you for letting me share.